All right, in this video, we're going over expressions and variables. In particular, our ultimate goal is to be able to evaluate and write down variable expressions. All right, we'll get to those in just a second. So first things first, one of the simplest terms that we have is the numerical expression. Now I'd like to pause here for a second and backtrack a little. Why are we starting off with vocabulary? Remember when we were looking back at our list of the must-have standards, the things that we absolutely have to be able to do? We had that list, and vocabulary is part of it. In particular, there are a lot of things that if you don't know what the directions are asking you to do, and if you don't understand what the problem is even saying, how can you do this stuff if you don't understand what you're supposed to do? You may know the steps, and you may know how to get the answer, but if you don't know that you're supposed to do it, you can't use the good skills you have if you don't know that you're supposed to start that way. Which is why we'll always begin with some relevant vocabulary. That way we can understand what the questions are want us to do. Coming back to this now, a numerical expression is fairly straightforward. It's based on add, subtract, multiply, and divide numbers. My board's kind of glitching out on me a little bit. Anytime you choose to add, subtract, or multiply, divide numbers, that is a variable expression. You've been doing them for years and years and years. For example, Jackson, give me some numbers and tell me to do something with numbers. What have you got? Okay, so you told me 20 added with 16. That's a variable expression. I'm sorry, a numerical expression. We're just combining numbers by adding, subtracting, multiplying, or dividing. That's all. Brianna, will you give me another pair? 17 divided by 24. Absolutely. That's a variable. Oh man, I keep saying that. That is a numerical expression. We can also make them a little bit more complicated. We don't have to use just two numbers. We could have 17 divided by 24 plus 6. That's still a numerical expression. As long as we're combining numbers, we have a numerical expression. Coming to the next one, a variable pretty simply, a variable is going to be a letter. But they're letters for things that for numbers we don't know. Right? Here's an example. How old is Mr. Gartner?
70.
Okay, so we've got a guess of 70. Any other guesses?
64.
60, 54. I heard guesses of 58. The point is, do we actually know how old Mr. Gartner is? No, we don't know how old he is. Now, you can take a guess at 70, you can think it's 70, you can think it's 54, but are any one of you willing to bet your life that you're correct?
No.
But,
Yeah.
well, that's a situation then where Mr. Gartner's age is a number, and we don't know what it is. So we can use a letter to represent that unknown age, and I'm just going to use a G for Gartner.
Awesome.
That's a variable. And of course, these could be used to represent anything. Let's say, how about the distance from Los Angeles to New York? Do you know the exact distance between Los Angeles and New York? Okay. How much is it? How far away is it? 6 miles. A little bit more than that. How far away are Los Angeles and New York? 5,000 miles?
I heard it was like an hour.
3,000 miles? The point is, just based on a guess, we don't know exactly how many miles it is. And so that's another situation. It's perfect for us to use another variable. We could use a variable like d for distance. We don't know what the number is. Obviously, there is a number, but since we don't know it, we'll use a letter. A variable expression, then, is just like a numerical expression. You will still add, subtract, multiply, or divide. Whoa, that's not coming out right. Let me fix that. Oh, man. So we'll add, subtract, multiply, divide numbers. That's the exact same thing as a numerical expression. But the only thing that makes it different, we'll also add, subtract, multiply, divide variables. We're working with unknown numbers. So we could have something like an example there. We could take Mr. Gartner's age and add it to the distance from New York, between New York and Los Angeles. That's a variable expression. We're adding a couple of variables. And we could do other pieces. For instance, let's say I'm going to use P to represent how many pennies does it take to weigh 1 pound of pennies. Well, do we know that? We don't know how many pennies it takes to make a pound. But we can still use a letter to represent however many that is. Well, if I now have 13 pounds of pennies, I could take and multiply 13 times the number for 1 pound. That's another variable expression. We can combine numbers and variables to create expressions. That's all they are. One of the main skills we have for this one, for this topic, we want to be able to evaluate a variable expression. Evaluating is pretty simple. Evaluating a variable expression just means that we'll take a number, plug it in for a letter, just replace it, and then we'll crunch the numbers to see what we get. A little more formally, we substitute a value into a variable and evaluate the expression. I'm not going to put an example down here because we have a couple of examples coming up a little bit later in the video. Lastly, we have verbal model. I'd like you to come back on this one, Ethan. Just read this for me, please. Yeah, this part right here. Just read that. Okay, so that's saying 20 plus 16. That's a verbal model. All we're doing to create a verbal model is read what we've got written, and you just write down with words exactly the stuff that you read. Take this one for me, Brianna. Read that one. 13 times P. So all we'd have to then note is a verbal model, 13 times P. That's a verbal model. You're just writing out with words the stuff that you see written in math. Now I want to pause and ask another question too. Why are we doing all this stuff with letters? We had all these pieces earlier in school where we could just do everything with numbers and things worked out perfectly fine. Why do we now need letters? For instance, think of this. When you were back in, first started learning how to multiply, you do pieces that were like, okay, what's 14 times 7? So you'd multiply 14 times 7 and you'd come out and get an answer. You wind up with 98. Well, what if I phrase the problem differently? 14 times some unknown number gives me 98. What is that unknown number? Well, what is the actual number?
7.
Yeah, we know it's 7, and we know it because we just did the forward way. Well, consider this piece. Now what is it? 22 times something is going to equal 132. What's the answer? This is why algebra was invented. I'm sitting here using a bunch of question marks to mean some number that we're trying to find, some unknown number. Rather than writing them out with a bunch of question marks, we'd instead just simply say 22 times some number equals 132. And we're going to spend a lot of time in the class learning how to work backwards, because really that's what algebra is all about. When you're in elementary school, you learn how to work forwards with numbers to get an answer. Algebra is about working backwards to get the answer. Okay, continuing our notes. Evaluate a variable expression. Well, what does evaluate mean again? Just plug it in. Plug a number in and see what you get. Our directions are telling us b is equal to 90. So back here, we're going to replace the 90 from that b. That's really all we have. We're just taking 3 times b, plugging the 90 in and getting 3 times 90. So what's 3 times 90?
B.
So you're absolutely right. 3 times 90 gives us 270. That's done. That's all evaluating is. You just replace a number with the variable, or I said that backwards. Replace the variable with the number and see what they wind up giving you. Let's do the same thing down on the second one. Let's start by reading the problem. What is this piece right here? What is the expression? X plus y. And so we're going to substitute in these values. We know x is equal to 9. And so we can replace the x with a 9. We can replace the y, because y is equal to 5. We'll just replace the y with a 5. And we can see exactly what is going into our boxes for our notes. X plus y is the same thing as 9 plus 5. So put them together now. What's 9 plus 5? We've got 14. We're done. And here we have another expression. Let's start by reading the expression in problem B. What is this? Great. I'm really glad that you made the observation. We don't have a symbol in between the x and the y. So what is it? One of the pieces that we have to understand, if we have two variables right next to each other, even without a symbol written, this is understood to mean x times y. It's just a piece of notation that you've got to get used to using. Even though there's not a times symbol written, we know it's there anyway. So we now have x times y. When we plug them in, that's 9 times 5. It's not just 95. We have to remember that multiplication is still there. So what's 9 times 5?
45.
We've got our evaluation. We're done.
What's the first page? 31.
All right, now let's see how we can transfer this set of skills. We want to be able to create an expression for something outside the classroom. So here we're looking. You have a 350-page manuscript that needs to be edited very quickly. Now, I can't speak for you, but do you really want to sit down and read and edit 350 pages of a book? That would take you a while. So that's a job that you want to split up. You don't give it to lots and lots of people. you're going to divide the number of pages among several editors. You want to give the same number of pages to each editor, so use a verbal model to write a variable expression of the number of pages given to each editor. Well, do you see any clue words here? Read through it again and find out the clue. There's a word in there that just is huge. Right here. We're going to divide the number of pages. It's telling us what we need to do. We're going to do division. And so we're looking at this and saying, at the bottom, let E represent the number of editors. The word divide indicates what? Exactly, we're going to have to divide. Working downward then, the number of pages each editor has to do will equal the total number of pages divided by we've got it. We have to divide it by the number of editors. But we have those things. How many pages were there? We had 350 pages. How many editors were there? Several. So how many is several?
7.
Is it 5? Is it 10? Is it 50? Is it 7? How many editors are there? We don't know. They didn't tell us how many editors. They just said several. Well, there's definitely a number of editors, but we don't know who they are. We don't know how many there are. That's why we use our variable. That's our E, the number of editors. And so we wind up with the number of pages for each editor is 350 divided by E. Now, I would like to make a note here. There's a very important concept just in terms of how we choose to write things. Once we start doing algebra, we don't usually use the divide symbol very much anymore. It's more common to write things out with the long fraction bar. This piece here of 350 divided by E is the exact same thing as using a long fraction bar. Do you remember when we were looking at our must-have standards? They had a piece there that said you have to be able to create and solve proportions. The main reason we choose to write division out this way is so that when we start working with proportions, one of those really, really critical, important things for us, writing division out this way as a fraction makes solving and working with proportions much, much, much easier. Proportions are easier to understand when we choose to write things out this way instead of writing them out that way. Moving forward with the class, you should expect the majority of the time when we want to write out division, we're not going to use the divide symbol. Instead, we're going to use the long fraction bar. Okay, let's run through a couple quick examples then. Evaluate when x is 12 and when x is 8 and y is equal to 2. So let's start by reading this. What is this? Okay, x plus 12, which you're absolutely right, Amaya. We'll substitute it in, and that's 8 plus 12.
20.
We're done. That's all we need. Our homework should just look like that. We're plugging in the information and then crunching the numbers. Let's read the next one. What have you got for the next one, Justin? Okay, x minus y. And when we plug those numbers in, x minus y becomes
8 minus 2 equals 6.
done. 8 minus 2 equals 6. What about the next one? Okay, we've got division there. X divided by y. So 8 divided by 2 gives us 4. And we're done. Consider this last one. the last thing we'll do here, let's write a variable expression for that. Well, let's start by finding the keywords. What are we going to be doing? What does this word product mean? Yes, you've got it. Product is going to tell us to multiply, so multiply what? 72 multiplied by a number. So what number? 72 times 10, 72 times 50, 72 times 5, 72 times what?
32.
We don't know what number. They didn't tell us take 72 times 3, they just said a number. And since it's a number and we don't know which one it is, that's exactly why we use variables. We'll make up a letter for it. So make one up. What letter do you want to use for this number we don't know?
A.
A? That's fine. We can use 72 times A and we're done. A number is telling us an unknown number. And unknown numbers are the variables. We're finished.